There's going to be polynomial long division in this explanation. I am not going to write the polynomial long division by hand. I don't have enough room to do it. But you can see it done if you put in this polynomial, the original question, x to the fourth minus 25x cubed plus 235x squared minus 995x plus 1624, and then the other polynomial that I'm about to show how to find as what you're dividing by, it will spit out the answer to you, and then you can follow along if you don't know how to do polynomial long division by hand. But here's how you find the polynomial you're going to divide by. One of the zeros, x equals 5 plus 2i. This is a complex zero with non-zero imaginary component. They always come in pairs. If one is 5 plus 2i, the other one is x equals 5 minus 2i. So the question says find all zeros. One is given, 5 plus 2i. Here's another one, 5 minus 2i. Now, how do I turn those into factors? Well, I'm just going to subtract 5 on this one. Subtract 5 from both sides, subtract 2i. X minus 5 minus 2i. And really, I should write equals 0, but I'm not going to because I don't need the equals 0 part right now. This one, I'm going to subtract 5 and add 2i to both sides. X minus 5 plus 2i. So those are the actual factors that come from these zeros. The zeros are 5 plus 2i, 5 minus 2i. They have to come in pairs like that. So now I will multiply these together and get a polynomial. That's what I'll use to divide. I'll divide this original polynomial by this. And again, you can do it by hand or put it into a polynomial long division calculator. If you don't know how to do polynomial long division, check out what that one shows. It shows all the steps, so you'll be able to follow along. X times x is x squared. I'm just multiplying every term by every term in the first one by every term in the second one. X times minus 5 is minus 5x. X times 2i is plus 2ix. And I'll write like terms under each other so I can easily combine them. Now I'm going to negative 5 times x is negative 5x. Negative 5 times negative 5 is plus 25. And then negative 5 times 2i is minus 10i. Now I'm going to take this minus 2i times x is minus 2ix. Oh, look, those will cancel. Minus 2i times minus 5 is plus 10i. It's a terrible 10i. Those will cancel. I'm just going to cancel them right now. Those cancel. Negative 2i times 2i. Negative 2 times 2 is negative 4. I times I is negative 1. I squared is negative 1. Negative negative 4 is plus 4. So when I combine like terms, I get x squared minus 10x plus 29. And now here's the URL, emathhelp.net/en/calculator/algebra-1/polynomial long division calculator. I can plug the original polynomial in there and then divide it by this new one I just found, x squared minus 10x plus 29. That's a polynomial formed by these two factors made up of the complex zeros. And again, on that one, it shows steps so you can follow along, and it will spit out the answer, which is, I'm scrolling to the bottom to get the answer, x squared minus 15x plus 56. So that's a simplified polynomial, x squared minus 15x plus 56. So that's what's left when I divide the original polynomial by these two factors based on these two complex zeros. So now I could do factoring, find the factors of 56 that add to negative 15. How about negative 7 and negative 8? 8 times 7 is 56, and they can both be negative. Negative times negative is a positive. So I get x minus 7 and x plus 8. Those are the factors. And if I set each one of those equal to 0, I'm going to get the 0, 7, and negative 8. X minus 7 equals 0. I would add 7 to both sides. X equals 7. Hold on. I wrote plus here, and it's supposed to be minus. It's supposed to be minus 8. I was doing that to test you. So again, the zeros are plus 7, x minus 8 equals 0, x equals 8. So the zeros are 7, 8, 5 plus 2i, 5 minus 2i, and the factors are x minus 5 minus 2i, x minus 5 plus 2i, x minus 7, x minus 8. And you're going to have to do polynomial long division. This polynomial that you made with those first two factors, you're going to use that to divide the original, and then you get this quadratic, which then you can factor. So there it is.